Matt, where are you, Matt?
You gotta go to the first slide.
Oh.
Woo! Alan, hit it. High fives, people. High fives. High fives. Woo!
Woohoo! Here you go, Matt. You need to put this on. All right.
Woo!
Woo!
Gotta make an entrance or what?
All right.
You all didn't think I was coming here to talk about being a superstar without looking the part, right? Well, please make sure we get audio going. Yes, please. Adrian, are you picking up anything? Or is... Okay. Say some stuff.
Yes.
Awesome.
So the virtual world is coming through the laptop, by the way.
All right. All right, so let me make sure. Yep. Awesome. Welcome, everybody. Thank you, OISF, for having me. I'm glad to be here again. Love this conference, always have. For those who don't know me, my name is Matt Scheurer. My topic today is becoming an IR superstar. I came dressed the part. I want to help all of you learn how to become an incident response superstar. So, I need help, people. I am a little more than 100 people away from hitting 1,337 followers on Twitter to have elite status. So if you're not following me on Twitter already, at C3RKAH, please follow me there. You can also hit me up on LinkedIn. And also, so you're not scampering for notes, if you go to slides.dfirmat.com, that'll take you to my GitHub repo, and you can get a copy of the slide deck there. So that way you can focus on the talk. See some pictures here. I'll pause just a moment.
Not gonna pose? Or was that your pose?
All right, we'll begin. So what I do, I work for a big, well-known organization as an AVP of Computer Security and Incident Response. I still think of myself as just an engineer, but I've got a lot of years of experience. I've done DFIR stuff for quite a while, so that's what I want to talk about today. I'm also a podcast host for the Threat Reel podcast with my co-host Micah Brown. We've been on hiatus for a bit. I'm hoping to get out a new episode before Hacker Summer Camp hits. And I'm just going to pause here for a moment while they fix whatever stream issue is happening online. So bear with this. I do want to note when this talk runs late, don't blame me for putting the schedule behind. Somebody wouldn't stop talking at the beginning, and now they're fixing technical issues. So when the whole schedule's running late, not my fault. We good to go? All right, I'm done giving Dr. C a hard time. Thank you. All right, let's go. Maybe. Oh, you broke the clicker, man. Come on, dude.
See, this is why I don't want to do virtual. Sorry.
No worries. Yeah, I still don't have the clicker back, and I probably messed something up. More technical issues. Yeah, all right. I'm good. Are we good online? We're good here in person. I can say that much. All right, let's go. So, I do some volunteer stuff. I'm an official Hacking is Not a Crime advocate. Check it out as hackingisnotacrime.org. I'm also a WAMSA, which is the Women's Security Alliance Technical Mentor. If you're looking to mentor women into information security, Or if you're a woman that's interested in pursuing a career in information security, a great organization, check out their website, wamsa.org. They're always looking for mentors and mentees. So I do have a day job, but the opinions expressed today are not the opinions of my employer. They don't reflect their ideas. I'm speaking solely on my own behalf, so don't blame them for anything I say. Today's agenda, we're going to cover the baseline technical skills and knowledge required for incident response investigative analysis, and then we'll wrap up with Q&A. So why this talk? This talk is largely inspired by job candidates that I've participated in interviewing for level 4, that's principal security engineer level positions, and finding experienced IR candidates ready for that level of work is very challenging. The purpose of this talk is to help fill the knowledge gaps that I've seen, covering where aspiring IR analysts and engineers should start, and then build upon their knowledge. And so let me just say this. I've said in a lot of talks where I didn't learn anything. That should not be this talk. If you honestly get through this whole slide deck and come up and say, Matt, I didn't learn a single thing sitting in this talk, come talk to me. We need to chat about career opportunities. All right, so the role of incident response. Incident responders, we answer the classic who, what, when, where, why, and how questions when we look into security incidents. Aspiring incident responders actually possess a working level of knowledge and preferably firsthand experience in each of the following information security disciplines. Defensive security, which is usually pretty obvious. People don't think about it, but offensive security skills are incredibly helpful when you're doing incident response. And just knowing what the tools and techniques that are being leveraged. And we're going to talk about that a little bit later in this talk. And then digital forensics. We've got a great follow-up talk that Scott's going to give on malware analysis. That's going to be awesome. This should segue beautifully into that. So when incident response starts, sometimes a user will say, hey, something doesn't seem right here, and they'll report it. But most of the time, you're getting an automated alert. And those are things from your SIM, your SOAR platform, antivirus, your endpoint detection and response, network detection and response. Sometimes they combine those two, call them XDR. And then your IDS and IPS systems will send alerts. So that's probably the number one place where incident response begins. So diving deep, while working with information from an organization's SIM, SOAR, AV, EDR, NDR, XDR, and IDS, IPS, it's a lot of alphabet there. While those solutions are critical in an enterprise environment, please don't become too reliant on any one of those or maybe even a collection of those security tools alone, because learning and developing a better understanding of the properties of files, the underlying activities that trigger those alerts is paramount to becoming a better incident responder. So I want to talk about IR dispositions, and most of you hopefully know this, but just in case you don't, a true positive is classifying malicious activity as malicious. False positive is incorrectly classifying benign activity as malicious. And my good friend Micah, who disappeared on me, likes to say there are no false positives. There are only poorly written rules. And there's a lot of truth to that, right? True positives really, in a perfect world, are the only thing you would have, where false positives are the things that you would never get. Now that's a perfect world, pie in the sky, never really going to happen, but those are what you want to strive for. True negatives are generally the things that you just don't even want to know about. They're classifying benign activity as benign, and then false negative is incorrectly classifying malicious activity as benign, and that's certainly the worst outcome because you have bad stuff happening and you don't even know it. So I'm going to talk about OS basics. So specifically, the Windows operating system and Linux. But knowing how to review the processes, the services, and the daemons that are running and their impacts on system and CPU memory utilization, that's pretty important to knowing what's going on a system. In Windows, you generally start with like the task manager. You have services.msc, and you have other things like Process Explorer, Process Monitor, and those sort of things as well that you can optionally have. Linux, just understand that the PS command is going to show you what's running on a box. And then top, or htop if you have it, which is a little nicer to look at, will kind of show you what's running, how much memory it's using, how much CPU it's eating up. those sort of things. So these are the things that can kind of help you pinpoint what's worth looking at on a system and investigating, particularly when you hear next about malware analysis. Like those are kind of the things that help you dial in to what you're looking for, or they can. It's not perfect, but generally that's a good place to start. So file system basics. Knowing where things are supposed to be located on an endpoint is really important. Conversely, knowing where things shouldn't exist but are on a system are also vitally important in incident response. So understanding the Microsoft Windows file system and where those things are or shouldn't be, Linux file system, and then depending on your environment, maybe even Mac OS, depending on how much it's prevalent within your environment, it could be important. I'm not really going to focus on that, but I did want to briefly mention it. So file system basics. Understanding where the user directory is. On Windows, hopefully most of you know, it's just C users and then the username that's logged into the system. Well, on Linux, it's going to be under /home/username. And some of you might be thinking it's pretty basic stuff, but you'd be surprised the candidates I talk to, they've got nice degrees, a laundry list of certifications, and they have experience even as security engineers in big organizations, yet they don't readily know where that is. No, absolutely not. I just told you where it is. Why are you asking me if I know where it is? Come on.
Big organization.
I'm a college dropout with a Security Plus certification. That's not real impressive educational credentials, but I know my stuff. All right, file system basics on Windows. So most configuration settings are really stored in the Windows registry. And so those are, when you pull it up, it looks like one big long list of stuff, but it's actually different things sort of mashed together called hives. And so you have HKey local machine software, HKey local machine system, HKey local machine SAM, which is where you have your credentials and it's a prime target. And then HKey local machine security. And then you also have HKey users default and HKey current config. And important paths to know are system root which is usually the C drive, /system32/config. And then also I want to talk about the /backup folder inside of there. Sometimes it's kind of hard getting a live Hive file on a running system. So the cool thing is you can check in the regback folder. If it hasn't been disabled in your environment, you might have registry hives there that are much more easy to pull off a system and analyze. The other thing you can do is if you have the live hive and you have the reg backup, you can actually compare those two and see if things have changed. So if you have a point in time backup that you can compare, you might be able to tell from that what's changed on a system. And then also the usually the user profile environment variable, ntuser.dat, so that'd be C:\users/username/ntuser.dat. Again, another one of those hives, right? And so you want to open those up on a Windows box with regedit. regedt32.exe is an older, and now it's just kind of a pointer back to regedit.exe. And this isn't all-inclusive. There's a lot of third-party forensic tools and things like that that you can also use to analyze these things. File system basics on Linux. Most Linux configuration files are stored under the /etc folder or within subdirectories inside of the /etc folder. Some noteworthy file there are the passwd file, which again has like the list of usernames, and that's usually pretty easily accessible by anybody with any level of access to the system. What's a little more protected is the shadow file, which has the basically salted hashed version of the credentials for the system, and it's a juicy target for threat actors because if they can grab the shadow file, they can do offline password cracking with something like John the Ripper and a bunch of other tools, but that's certainly one of the prevalent ones. Really just to get familiar with the Linux operating system, if you're not terribly familiar with it, the Linux Foundation has something called the FHS, the File System Hierarchy Standard. It's a great reference for where paths are on a Linux host and why they exist in that path. So if you've never looked at that and you don't have a ton of experience with Linux, have a look at it. Great information. And by the way, when you download the slides, all these are hyperlinks back to these resources, so you can then go back and retrieve these documents, get the links, all that good stuff. So incident response skill, understanding logs and PCAPs. Really the bedrock and starting point for most security investigations starts with the available logs and packet capture files if you have them. Sometimes that's not always practical if they are using encrypted protocols, for example, and you don't have the key and so forth. But if you have decrypted packets, that's like one of the best things ever. So SIMs are great, but here's why you don't want to depend on them exclusively and focus your core knowledge only on, hey, I investigate stuff out of the SIM, because they're not perfect. So SIMs, the licensing on those and the resources to run them is pretty high. So what happens is these things are configured just to capture specific events, event types, and important details might actually be tuned out and not getting to your SIM in the first place. And so, you know, it could also be you have the logs in the SIM, but they're not parsing correctly. So when you try to search the SIM, you're not seeing everything that you think you are. And then input sources might become broken. You don't have good health checking, or the health checking fails on you. You might just totally miss something there. And then again, these things are very resource intensive. So if the system is running full speed, you might have correlation searches that simply don't run. They get skipped out of the system. So that's why you don't want to depend solely on what's in a SIM. So what you do want to understand is native logs and where they exist on various endpoints. It's really important. So Windows logs, Linux logs, server logs, and application logs are usually the big ones I think of. Windows logs, so the four primary ones that have been around forever and ever and ever are an application log, the security log, the setup log, and the system log. Though there's a lot of other ones now if they're enabled. And they exist as .evtx files, and they live under the C:\Windows System 32 folder /winevt/logs. And then they can be opened using the event viewer, event_bwr.exe on a Windows host. Understanding sort of how Windows logging works at a high level, just know that Windows logs various event types based with specific event ID numbers. I don't have time to go through a lot of examples, but what I did do is put a link to Microsoft's own documentation of what they say is important to monitor. And if Microsoft says these are important events to monitor, they probably are. They created the OS after all. At a high level, also understand that you have various logon type conditions. And understanding those is also important. So if you have a logon type 10, you know somebody is trying to RDP into a host from elsewhere. These things are very telling when you're trying to investigate and put together that picture. Linux logs, most Linux logs live under the /var/log folder, and an example is /var/log/syslog. Typically viewable using any preferred text editor. You can even, you can throw the cat command, the more command, or the less command to peruse log files. You can also use the head command to get the first X number of lines out of a log file, or you can use the tail command to get the last and often usually the newest log entries. You can even use tail-F to live follow the log file and basically keep track of what's happening on the system pretty much in real time. More stuff about Linux logs is they are often time-stamped in epoch time. So back in 1970, when the Unix operating system was created, they took the epoch, or the birth, if you will, of the Linux OS as the year of 1970. So a lot of times these things are in relation to January 1st of 1970, but they're just a string of numbers and they don't really make sense to look at them. So you're going to want to use a converter to translate those epoch times into human readable time. And the other important thing when you're doing investigations is to understand your timestamps. Is everything local time to where you are? Are you a big national or international business? You might have everything set to GMT. you might have a mixed case scenario where you got some systems on local time and others on GMT, but you have to sort of correlate those together to put together a picture of what happened. So just being aware of that is pretty important. Server logs, just be aware that various server applications can store their own logs independently of the host OS's native logging. Default log paths and names are also sometimes changed because they're configurable. By default, Windows IIS server logs are stored in numbered W3 SVC folders under the C drive, inetpub/log/log files. But again, that could be moved. It could be a D drive or an E drive or something like that. You kind of got to know the environment. You might have to look at how IIS is configured for the logging to know where you should be looking. Application logs, be aware that various applications might store their own logs independent of the host OS's native logging. So sometimes things that you run on a Windows host, for example, will use the event viewer and are viewable there. Sometimes they just have their own separate log files in a folder somewhere. And then sometimes you have logs that reside on an endpoint itself. Sometimes you have in a central management console, and sometimes both of those conditions are true. So like a lot of EDR and antivirus solutions, for example, will have local logs on the endpoint, but you also have in the central console where those logs are. And so sometimes you can get those, but it's just something to be aware of so that you know where you should be looking. And then incident response skill, networking basics, just understanding the basic concept behind TCP and the three-way handshake versus UDP as a connectionless protocol. And this is not an all-inclusive list. I just threw a few quick examples here. But you got 22 SSH, you got your web ports. A few. And, so you got SMB, you got RDP ports, UDP 53, which is what DNS is primarily communicating over. But here's a list that's got a really great listing of common ports. So check it out if you're not terribly familiar with those. And then learn about port scanning. If you haven't dabbled with Nmap, give it a try. Network packets, being able to analyze network traffic data is really an important incident response skill. So learning how to create, save, and analyze packet capture files, or PCAPs, and you can use things like Wireshark, Tshark, TCP dump, WinDump, a whole host of others. But those are some of the more popular ones. And if you're looking to get good with Wireshark, I actually gave my Wireshark workshop at OISF in the March meeting, I believe. And there's a link. You can download the lab, the whole lab. You just unzip the file, and the text file in there is the lab guide itself. Walks you through every step of the way to do some cool exercises with Wireshark if you're not terribly familiar with it. So, yes. I don't touch on that in this talk. But and again, obtaining decrypted packets is always the best, but it may not always be feasible, particularly in larger enterprises. A lot of times you have to look at commercial solutions for the newest protocols that are being deployed, and that stuff can get pretty darn expensive. OWASP skill of understanding the OWASP top 10 is really just kind of important common knowledge. It's really sort of what basically web application developers have prioritized a list of, if you're trying to fix issues in your web environment, or you're looking to figure out what should we tackle first, OWASP top 10 is the go-to for that. But there's a ton of information out there. It breaks down what the vulnerabilities are, often how they're exploited, and how to fix them. So just be familiar with that. Web requests, the more common methods are get, head, post, and connect. You see those all the time. Potentially concerning HTTP request methods could include put and delete. Now those may or may not be normal. Like if you have a photo bucket web app on your site, it would be probably pretty common to see puts for a bunch of different files or deletes for removing files. But if you have a contact form, probably shouldn't see those kinds of things targeting that. So you kind of have to know the environment, figure out what's being attacked. And then some of the lesser seen ones that you might run across are options, trace, and patch. But if you're doing incident response, understanding the HTTP response codes is really important. And these things are basically broke down in a series. Unless you're using an old, very old version of HTTP, you're not really going to see the 100s, which are the informational ones. But the 200 series means that the server accepted the request. Now, the result may or may not be what was expected. So sometimes those are things that you have to look into, and you may have to drill down deeper to understand, okay, did this request actually work on the web server or not? 300s are generally your redirects, so your 301 permanent redirect and your 302 temporary redirects. Just when you see those kinds of things, that's kind of what you're looking at. 400s are basically a client error response and often, 404 is a very popular one. That means something was requested on a web page and the file or the page, the page file or whatever file it is just simply isn't there. It's not found. And so, that could be indicative of an attack. It could just be indicative of a page that's coded and is trying to pull in sources that are at the wrong location or just don't exist there anymore. And then 500 is sort of the flip side of that. That's the server gets this request, has no idea what to do with it, so just kicks back an error message. But that's coming from the server back to the client. Incident response skill of SQL basics. So understanding structured query language to help identify injection attacks. If you look at the OWASP top 10, injection has been on that thing forever. Pretty much since its inception all the way through to today in modern times. SQL injection is one of the more popular ones. I believe they consolidated it last time I looked to include all kinds of injection, but being able to identify SQL injection is really helpful. Here's a couple courses that are free, quick, and easy to try. So highly recommend having a look at those. And then data encoding. I want to talk about this just a little bit. So learning to recognize and identify the most popular data encoding string formats is pretty important. I don't know if do I have a laser on here? Oop, doesn't look like it. All right, so, sorry Adrian, I'm gonna move on you here. I have an encoded example of the string hello attendees. What that looks like in base 64, there's some traits here that will help you identify this as base 64. So we have alphanumeric. It's the full alphabet. It's A to Z, or very close to it, given whatever particular string you're looking at. But it also, the characters, the text characters are mixed case. So you have uppercase and lowercase. And then one of the real big telling signs at the end of it, if you don't have the right number of bits for the encoding and decoding to work, the equal sign is what's called a pad to make sure that you get to the proper number of bits. So when you see 1 or 2 equal sign, there's a good chance it's base 64. Now there's other base encodings as well, but I usually start just trying with base 64. ROT13, you might be thinking, well, that's crazy. But believe it or not, Microsoft uses ROT13 quite a bit. I'm going to cite a specific example later on. And so what's telling here is you have alphabetic characters that aren't necessarily human readable if you don't know the secret. But what's interesting here in the artifacts is you notice that the case matches the case. So in the alphabetic string, but then you also notice that the space matches the space and the punctuation doesn't change. And so when you see those sort of things, I don't think that's quite reach, but all right, I'm going to fall off the stage here in a minute, so that's going to be fun. I hope there's a hospital nearby. Oh, awesome, good deal. I'm in good shape then. All right, so yeah, so what you have is with the these are the kinds of things that can help you think like, okay, I've got spaces in here. Looks like I've got, case that might match something. Punctuation doesn't change. why not try ROT13? It's either that or some other substitution cipher. Good chance of it. And then hexadecimal. So generally, that's when you see pairings, alphanumeric pairings, and sometimes these are prefixed by like 0x in front of them. Sometimes they're just number alphanumeric pairs. But when you see pairs of things, they're alphanumeric, but the letters never go beyond the letter F. So they're A through F. You never see G or higher in the alphabet. Good chance you're just looking at hexadecimal there. So that's real quickly, and again, not an all-inclusive list. There's tons and tons of encoding formats out there, but in the wild, those are probably the three I personally see the most. And so file type identification is another important IR skill. Understanding what are called file signatures, magic bytes, magic numbers, file headers, whatever you want to call them. They go by numerous names I've seen, but they're important to understand because file extensions can either be removed or renamed to something else just to try to fool somebody as to what they really are. But what happens when you open a file in a text editor or preferably a hex editor with an ASCII output window is you can look for certain things at the beginning of the files and at the end of the files. And here's a great resource to a lot of these different file signatures. And so just a couple quick examples of that. If in your first few bytes in the ASCII you see MZ, it's actually the abbreviation for the person at Microsoft who created the exe file format. But when you see that MZ at the beginning of a file in the ASCII output, there's a good chance that's an executable file. Most likely it is. Even if the file extension isn't there, it's been renamed to .txt or whatever have you. When you see PK, that harkens back to the old PKware in PK zip days. And so that's the file header you get for something. And when you're looking at things, there's usually three that aren't human readable. There's usually three common threads here. It could be encoded, it could be encrypted, or it could just be compressed. And so when you look at the file header and you see PK, that kind of helps you know, probably compressed. I can probably rename it to .zip and extract it out and then inspect the contents. Yes? So actually, Notepad. Actually, in Windows environment, I do. So I like Notepad++ for small files. I actually prefer TextPad for large files because it, in a Windows system, can actually handle unimaginably large files without completely running the system out of resources. On Linux host, I actually like the ghex hex editor. So those are a couple of my go-tos. But I've also used, I think it's like SciText or whatever's in Remnux. I've used that one too, and kind of made peace with it once I figured out how to get the regex searches working how I wanted. So just, a couple examples. All right. Go ahead. Hexer. All right. Good advice. Thank you. I use it. I do. There's a few of us.
Always use that in a pinch. VIM. I think VIM now is more popular than VI.
Yeah, most of the time it's basically, you have a link. When you run VI, it's really running Vim in the background. But, everybody's used to VI. Well, maybe not everybody, but if you're used to VI, it's usually launching Vim on most Linux distributions these days. So understanding persistence, I don't have time to drill into tons and tons of examples, but the idea here is that if a threat actor gets a hold of a system, they want to maintain their foothold on that system. And things that are volatile will go away if the system just simply gets restarted. So persistence becomes important then to anybody doing offensive security, regardless of their motive, because they want to maintain and be able to reestablish that connection later on or keep it up the whole time. And so there are some specific ones for Windows and Linux. I don't really have time to get into these. And this, I promise, this is not like the 10,000th talk out there on the MITRE ATT&CK framework, but here's a good resource on MITRE that talks about very specific ways that persistence happens on a host OS. And then identifying file execution, understanding how to know if a file executed on Windows endpoint. So a lot of times your EDR, XDR solutions will tell you, but if you don't have that, and I talked about ROT13 earlier, but in the Windows registry, HKey, current user, software, Microsoft Windows, current version, Explorer, user assist, and then you have the GUID, and then count. In that key are sort of define the things that run, and those are actually ROT13 encoded. So if you're looking to figure out did notepad.exe run or not, you don't search the registry for notepad.exe. You basically ROT13 encode notepad.exe and search for that in the registry. And this is, again, not an all-inclusive list, but also memory dumps, having a look at shim cache. The prefetch folder on Windows is also another good one. And so with prefetch, the idea is that anything runs on a Windows host it goes into the prefetch folder. And so the next time that file is loaded, it'll load faster. But things that have never run aren't going to be found in that folder. So that's why it can be another helpful one. And so one of the reasons Windows is so hard to secure, and compared to say Mac OS, Linux, all these other types of systems, is because there are a lot of file extensions that just simply run by default on a Windows host. If I get an exe file somehow from the internet and I double click on the Windows endpoint, what's going to happen? It's going to run it, right? Because that's what the OS is set to do. If I download a .sh shell script on my Linux laptop and I double click on it, nothing, because it hasn't been, the execute permission has not been set on that file unless I manually do so. So it just doesn't run out of the box. And there's so many of these things that here's a great How to Geek article that talks about 50 of these, and even they admit there might be more that we don't have covered that we don't even know about. But that's one of the reasons Windows is so hard to secure, is because you have all sorts of things that just simply run. And then evidence collection. So there's a couple of different methodologies here that I cite. One is the old RFC 3227, which is the order of volatility. Now, the idea behind the order of volatility is you want to capture the artifacts from an endpoint you're investigating from the most volatile to the least volatile. So, for example, things that are running in memory, that's going to disappear pretty quick. If you lose power or the system shut down on an endpoint, anything that's volatile is gone, like the contents of memory. The data that's on a USB stick that's plugged into that system are not likely to change or disappear too much unless there's some special software that's set to do just that thing. But generally speaking, the data that's residing on a USB stick is still going to be on that same USB stick, even if the system gets powered down, thrown in a closet for a couple months, pulled back out. So this is the idea, that you want to get the stuff that's going to disappear first, all the way down to like archival media. And here's the link to the RFC for that. It's a pretty similar list, but NIST has a guide to integrating forensic techniques into incident response. And it's, again, the same concept here of getting the most volatile data first. And they have a specific order in which you can do that. I'm not saying you have to stick to one or the other. It's probably a good idea. But if you want to deviate from that, it's no problem. But you probably want to make sure in an organization that you're documenting how you're doing it in what order, so that you can then later on say, well, this is our standard operating procedure to do it this way. But conceptually, you should have the same idea, getting the most volatile stuff first. So some tools for skill building. CyberChef. I gave a CyberChef workshop here at OISF, and very similar to the Wireshark workshop, you download the files, unzip it. The TXT file is the lab guide. Have at it. And there are also incident response and forensic tools in Kali Linux, believe it or not. Some of you may be thinking, well, Kali is more offensive security. That's true, but it does have tools like Autopsy in it. And so if you have a Kali instance, why not dabble in that? Remnux is specific for reversing malware. It's a great distribution, probably one I use fairly frequently. CNSIFT Workstation has some good stuff. You can actually combine those things. You can install SIFT tools into Remnux or vice versa. And then that's great for static analysis, but if you're trying to look at Windows binaries, those are Linux systems. FireEye has what's called Flare VM, and the idea is you can even download a trial version of Windows, install the Flare tools in it, and where that's helpful is because that helps you do dynamic analysis. So that helps you analyze how something really impacts a system when it's running live on the native OS that it was designed to run on. So another great collection of tools and utilities. I just have at it and dabble in some of the tools. Some really good stuff. And then some ways to build skills. The ANISA training labs, I've talked about those at OISF before. Some great technical content, absolutely free, and it's geared specifically towards incident response, and they've got some good forensic stuff in there as well. Participating in capture the flag events, great learning experience. I can't recommend it enough. I know I probably learned the most doing CTF things, just because it forces you to learn things maybe you didn't know before, or really refresh on things that you got really rusty on because you're trying to solve a capture the flag challenge. And then periodically have a look, again, not a talk on MITRE, but have a look at the tactics, the techniques and procedures in the MITRE attack framework. And really, from an incident response and detection standpoint, I really recommend understanding the techniques and the processes and procedures more so than focusing on the tools. Because if I can take my badware.exe file, rename it to goodware.exe file, and it defeats your security solutions, not a good detection. Also, if
Hello folks, Iron Geek here. Unfortunately, the microphone ran out of juice, so we lost audio for most of the rest of this video. Apologies for the inconvenience.
presentation. So good job. In case anybody's interested, this is it's the whiskey class. So we do have some extras that are available for sale, and we have some pint glasses from last year that if you're interested. So check them out later if you want. So very cool. All right, go ahead and get set up. While Scott is getting set up, folks, this is a hacker conference. I don't see enough black hats out here in this audience. I think we need to fix this situation right now. So, wave your hands and make some noise if you want a hat.
I need to change the batteries in the microphone.
Yeah.
Hello, everybody. Iron Geek here. Unfortunately, the microphone ran out of juice at about this point, so most of the audio until the end of the video is not there. Apologies.